Given vector u in component form, we're asked to find the magnitude and direction of the vector, where the direction is the angle in which the vector points measured counterclockwise from the positive x-axis, and we're told to give the angle in the interval from 0 to 2 pi radians. Let's begin by sketching the vector in standard position, which means the initial point is at the origin, and then from here, because the x component is 4, we would move right 4 units. And then because the y component is -2, we would move down 2 units. This would be the terminal point of the vector in standard position, and therefore this is vector u in standard position. Notice by sketching the x and y components, we have a right triangle on the coordinate plane that we can use to determine the magnitude of the vector, which is the length of the vector. We indicate magnitude using either single or double vertical bars. I will go ahead and use double vertical bars. Notice how the magnitude of vector u is the hypotenuse of the right triangle. And then the angle theta, or direction, is the angle starting along the positive x-axis, rotating counterclockwise to the vector, which is this angle here. This is the angle theta, the direction of the vector. And we can determine the angle theta using the fact that tangent theta is equal to the ratio of the opposite side to the adjacent side, or y divided by x. Just remember, and then solving for theta, we have theta equals arctangent of y divided by x. However, we do have to remember the output or range of arctangent is the open interval from -pi/2 to +pi/2, which means the calculator is going to give us the negative angle rotated clockwise from the positive x-axis to the vector, and therefore we'll have to add 2 pi radians to get the angle theta that we need. But let's begin by determining the magnitude, where the magnitude of vector u is equal to the square root of the quantity x squared plus y squared, which in our case is the square root of the quantity 4 squared plus the square of -2, which gives us the square root of the quantity 16 plus 4. The magnitude of vector u is equal to the square root of 20, but we need to simplify if possible. This will simplify if 20 has any perfect square factors, and since 20 is equal to 4 times 5, where 4 is a perfect square, this will simplify. The square root of 20 is equal to the square root of 4 times the square root of 5, and the square root of 4 is equal to 2. The exact magnitude in simplified form for vector u is equal to 2 square root 5. And now let's work on determining the angle theta. Theta is equal to arctangent of the ratio of the opposite side to the adjacent side, or y divided by x, which gives us -2 divided by 4. Simplifying, we have theta equals arctangent of -1/2. And now we go to the calculator. We do want to verify that we are in Radian mode, so we press the mode key, and we are in Radian mode because Radian is highlighted. So we press second mode for quit, and we enter second tangent -1/2, so -1 divided by 2. Remember, we cannot use the minus sign for the negative, or we'll get an error. Let me press enter. Rounding to 3 decimal places, we have -0.464 radians. But again, this is not the angle we want because it's not in the interval from 0 to 2 pi radians. We just found this angle here rotated clockwise 0.464 radians. So the angle that we want is coterminal with this angle, but it has to be between 0 and 2 pi radians. So we're going to take the angle of -0.464 radians and add 2 pi radians, or 1 full rotation counterclockwise, to get the angle that we want, which is the same as taking 2 pi radians and subtracting the reference angle of 0.464 radians. So going back to the calculator, for more accuracy, we could add 2 pi to this value here, which is more exact than the rounded -0.464. So notice how if I press plus 2 pi, it adds 2 pi to the previous entry. Rounding to 3 decimal places, because we have a 5 in the 4th decimal place, we round up, and because we have a 9 in the 3rd decimal place, we round to 5.820 radians. Notice how if we did the calculation shown on the screen here, it would not be quite as accurate. we would have negative 0.464 plus 2 pi. Rounding to 3 decimal places, notice here we have 5.819 radians. I'm going to go ahead and use the more accurate angle of 5.820 radians, which again is the direction of vector u, which is the angle starting along the positive x-axis, rotating counterclockwise to the given vector. I hope you found this helpful.